So in order to first solve number 7, I drew a diagram along with the forces. So there's a vertical force, normal force pointing directly up, there's gravity pointing directly down, and then there's a friction here, and there's a tension. The tension force, I broke it up into components. So there's the horizontal component is tension cosine 20, and the vertical component is tension sine 20. In order to first solve this problem, you should know that since this slide is traveling at a constant speed, the acceleration is 0. So the first question asks, what is the tension in the rope? So you want to write out the force equations for the y and x. So for the force in the y direction, there's a normal force plus the tension sine 20 minus the gravity, and because the acceleration is 0, that would equal 0. Same with the x. The force for the x is tension cosine 20. Subtract the friction, and it would equal 0. So you can plug in the known values such as the mass and the gravity. And make sure not to switch up the newtons and the normal force because they're both capital N. So once you solve like sine 20 and the cosine 20, I moved the normal force onto one side, and then I plugged this normal force right here onto this equation. So I got this, and then once you solve further, you get that the tension is 79.4 newtons. With this information, you could solve for B, which is how much work is done by the rope on the edge, the sledge, sorry. And so the work force equation is force times the distance times the cosine theta. So I got 79.4 newtons times 20 times cosine 20, which is 1,492 joules, or 1.49 kilojoules. And so C asks, what is the mechanical energy loss due to friction? And if you realize that the mechanical energy loss due to friction is also equivalent to the work done by friction, the problem becomes easier. And because the object is traveling at a constant speed, the force to the right would equal the force to the left. So what this means is that T cosine 30 is the same force as the friction force because it's traveling at a constant speed. So you can actually plug in T cosine 20 for the friction force. So the force is 79.4 cosine 20 times 20 meters times cosine 180. And then you would get negative 1.49 kilojoules. If you notice, this 1.49 kilojoules is the same as the work force from the tension because that the object is traveling in a constant speed.